we are going to see artificial intelligence in COVID-19 with deep learning approaches for diagnosis and treatment. Introduction. The World Health Organization proclaimed PHEIC in 2020 as a result of COVID-19's extensive spread, which affected many animal species and caused serious illness in some. Over 5 million individuals have been affected by the virus, causing the health system to collapse. It is vital to find quick, affordable remedies and diagnostic instruments. Chest X-rays and other non-invasive imaging methods are used to monitor COVID-19 and pneumonia. Convolutional neural networks are one type of artificial intelligence solution that were used to address image-related issues in medical practice and healthcare systems. Objective of the project. The COVID-19 pandemic has necessitated affordable diagnostic methods using chest X-rays. This project presents an AI-based technique using medical knowledge to detect and predict COVID-19 using SARS-CoV-2 CT scan X-ray images dataset. The technique uses extreme machine learning, recurrent neural networks, long short-term memory, and generative adversarial network for detailed treatment information. Requirements. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements needed are Python IDEL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload SARS-CoV-2 dataset. Using this module, we will upload dataset to application. The second module is pre-processed dataset. Using this module, we will read all images from dataset and then resize all images to same size and then normalize all images pixel values between 0 and 1 and split dataset into train and test sets. The next module is train GAN-CNN algorithm. The previous module's final dataset will be input to GAN-CNN algorithm to train GAN model and calculate its prediction accuracy. The next module is train LSTM algorithm. The preprocessed data will be input to LSTM algorithm to train LSTM model and calculate prediction accuracy. The next module is train ELM algorithm. The preprocessed data will be input to ELM algorithm to train ELM model and evaluate accuracy. The next module is predict diagnosis and treatment. Using this module, we will upload test image and then the model which outperforms other models will predict whether that CT scan image is normal or contains COVID symptoms, and if COVID detected, treatment details will be displayed. The last module is comparison graph. Using this module, we will plot accuracy comparison graph between all modules, all algorithms. Execution of the project. To execute this project, first we need to open the code folder, and this is the model folder in which I have pickle files and .h5 files which contains the algorithms information. These pickle and .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks such as making predictions on new data or performing specific operations. This is the dataset, this is the COVID dataset, and this is the test images dataset. This is the Python main code file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. Click on upload SARS-CoV-2 dataset. A dialog box will be opened. Select the dataset and click on select folder. We can see that it has confirmed that the dataset is loaded. Now click on preprocessed dataset. This is the sample preprocessed image. Close this image, and here in the text box we can see total images in the dataset are 2481, and these images are split into train and test sets. Now train set includes 1984 records and test set includes 497 records. Now click on train GAN-CNN algorithm. This is the GAN-CNN iteration graph, in which on x-axis I have epochs or iterations, and on the y-axis I have accuracy and loss. So for every increasing epoch, we can see that the accuracy is also increasing. and for every increasing epoch we can see the loss is decreasing. So we can say that the model is performing well. Close this graph and now click and here in the text box we can see GAN model's accuracy. The accuracy is 90%. Now click on train LSTM algorithm. This is the iteration graph of LSTM algorithm. Close this graph and the accuracy of LSTM accuracy is 79.9%. Now click on train ELM algorithm. The accuracy of ELM algorithm is 78%. Now click on predict diagnosis and treatment. A dialog box will be opened where we can see the test images. Select any of the test image. I am selecting 7th image and click on open. So here the blue color text says that diagnosis result is COVID detected. So for this image the algorithm has detected the COVID. Close this image. So in the text box we can see the measures to be taken, and if we scroll down we can see the medication details. Now click on again click on predict diagnosis and treatment. So this time we will select another image. This time I am selecting 14th image and click on open. So for this image the diagnosis result is no COVID detected, and we can see we don't have any details, the treatment details in the text box. Now click on comparison graph. So this is the bar graph in which we are comparing the accuracy of GAN, LSTM and ELM models, and we can see GAN accuracy is doing well. Close this graph and click on exit to exit from this tab. The conclusion here is the project used SARA-CoV-2 CT scan X-ray images dataset to diagnose COVID-19 using artificial intelligence. The project utilized extreme machine learning, recurrent neural networks, long short-term memory and generative adversarial network to generate new images and train models. And the model predicted COVID, providing insights into treatment.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.